All right, so we just had test number 2. We've talked a little bit already about the grades. If you want to meet with me individually, see me right after class. I am free. So we have one last packet. I've just given it out. It's got a big grid on the front, so make sure you have a copy of that. And I'll say a couple of things. So first, this is our last packet, and it's heading us towards our last test. Our last test is during the final exam period, but our last test is not a final exam. It is just a third test. It's not any longer than the test that we've already taken. It's not going to be any harder. It's not on a whole semester's worth of material. It's just on the stuff we're starting with today and ending with on the last day of class, all right? It's just a third test, but it happens during exam period, final exam period. I'm also going to say that if we count here, we see that there are 6 topics listed here. Normally our tests are on 8, so this last test is actually on a little bit less material. 6 classes worth of stuff instead of 8. So hopefully that'll make it a little bit more manageable. I know that the end of the semester is a very crazy time for many of our students, so hopefully it won't be too stressful having a little bit less material on this last test. I will also say that our third and final project is not assigned for like another week or so, but I just gave it out and you guys could start it tonight if this is a good time for you. If you have time to work on this, then start working on it. You should be able to do most of it, if not all of it, real soon as we get into the heart of this financial piece here, okay? The project itself is a physical document, and you are going to hand back to me that document filled in. There are Excel files that you're going to play with to help you answer questions on that document, and the Excel files are in Moodle. It makes reference to it in the document. It tells you to go to Moodle, tells you what the Excel files are called. You're going to use them to come back in and fill in the stuff on the pieces of paper. But again, the paper is what you are turning into me. You're not emailing me another Excel file for this project, all right? So officially, that's not assigned until a week from now, and then it's going to be due on December 9th. I will turn around as quick as I can and give it to you on December 11th, just so you have some feedback heading into the final exam. Any questions on the calendar? All right, so our last major theme of the course is about finances. We have 4 different classes on finances, and then we'll spend the last 2 classes talking about fractals. You might have heard of these things. They're not related to finances, but those are our last 2 pieces of the class. And just in terms of finances, you can see we've got a lot of different stuff. Today it's percentages and simple interest. Next class, something called compound interest. Then we'll talk about debt, and we'll be specific and think about credit cards and mortgages. And then we'll also talk about saving for retirement and IRAs and all that stuff. So I want to put it out there. Very early here in terms of finances. You guys come from a very wide and varied background, and some of you have a lot of experience with car loans and student loans and home ownership and retirement savings and stuff like that. Some of you guys are fresh out of high school, maybe don't have a credit card yet, don't own a home yet, and so there's a really, really large set of background that you guys come into this class with. So I just want to be sure that, I don't know quite how to say this, I don't want to offend anybody by talking about, like if I'm talking about something that you've got so much experience with, it's like, hey, I know exactly what a mortgage is, and why is Ian talking all this basic stuff about a mortgage? It's because the person sitting next to you might have no idea what a mortgage is and know very little to nothing about home ownership. So like you guys bring in so much different experience here, and so I just want to be really careful and just say that I'm starting at the beginning with all this, even though some of you might be very experienced with some of these aspects of your financial life. Okay, so that is that. Good. All right, so the grid on the first page is related to homework for class 25. You're going to rip it off later on when it's time to do that homework. On the back, it's another grid. Page 3 is a reference sheet that you're going to be able to use. You're going to bring that with you for the test. Skip past that. And finally, I think we start here on page 5. Okay, so I also have the new homework assignment for people that don't have the book. Anybody have the old edition of the textbook? Great. Anybody else? Old edition of the textbook? You're welcome. There you go. Thank you. All right. So the other thing I'll say, and then we'll dive in here, is that some of you guys are going to be really good at percentages, and that's going to help you tremendously in the coming classes. Some of you have some gaps in your knowledge about percentages, and you're going to have to do some work to fill those gaps in a knowledge of percentages is assumed here at this level. You've either taken Math 095 or tested out at that level, and percentages and decimals happen there or earlier. So if you need some extra practice on the basics of percentages and things like that, just see me outside of class and I'm happy to give it to you. But this is going to feel kind of quick for people that really are not so comfortable with percentages. All right, let's start with number 1. Jeremy. Okay, so there in the box is our basic formula for the definition of a percent. Yes. Thank you. So X percent really means X over 100. And in fact, that over 100 is buried in the word percent. Per meaning out of, and then cent has to do with 100, right? So percent out of 100. Chad? Great, thank you. Stephen, number 2. Okay, thank you. So I'm just going to write these as fractions and a little bit of space in between. So 19 out of 25, 49.2 out of 60, and then 124.8 out of 150. And it's not so easy to tell which one was the best, right? What makes it hard to compare these fractions? Not out of the same denominator. So what you could do is get the least common denominator, but instead we just all decide to use the same denominator of 100, which is just our baseline. So we're going to make everything out of 100. Now we're going to do this first one like this, equals some number x out of 100. And then there's going to be a shortcut that we can use on the other two. But if you don't know the shortcut, or if you're not quite sure on a test, like that's your basic definition. Something out of 100, that's what a percent is. So I currently have x divided by 100. I need to solve for x, which means this 100 needs to get out of the way. What's the opposite of dividing by 100? Multiplying by 100. So we're going to multiply both sides by 100, do it in a different color. And then cancel the hundreds on the right-hand side. And then use your calculator to calculate the left-hand side. What do we get when we type in 100 times 19 divided by 25? 76. That's good. Your score was 76. 76 what? Percent. 76 out of 100. Now we can think about it. You guys all have some knowledge about what a 76 means and whether or not you think that's a good grade. But you can think about 76 in a better way than thinking about 19 out of 25 because we've standardized it out of 100. Okay, so then what did we end up doing with 19 out of 25 just to get the answer? Oh, we multiplied it by 100. So it's a little shortcut. I don't think it's worth memorizing, but I'm going to take advantage of it in this next line and just say, okay, in this one, I'm just going to take the 49.2 divided by 60 and multiply it by 100. And that's my shortcut for finding the percent. Somebody with a calculator help us out on this one? There are lots of ways to do these. Exactly, or is there more? 82. Is this right or wrong? 82. Yeah, and so I want to put out there that lots of you guys have experience with percentages and fractions, and if you've got techniques that work for these problems, continue to use them. I'm not saying you have to do it this way. What I'm trying to do is provide some standard way to do it, some general way to do it, but if you got something that works, keep doing it. Okay, so 82, that's better than 76. I couldn't tell that 49.2 out of 60 was better than 19 out of 25, but now it's like comparing apples to apples, and I can tell. So the last one, 124.8 over 150, just multiply that by 100, 80, 83.2%. Which one's the best? That one. Okay, it's easy to tell because we've got the same baseline, that same 100 as the denominator. All right, let's look at number 3. I think we're back to Griffin. Okay, so first thing I want you guys to do with your neighbors is convert 3/20 into a percent, just like we did, and then calculate what the tip should be if the meal costs $56.80. Everybody got 15%? All right, and then $8.52. Good, good. Okay, moving on to 4. Casey. Okay, so first option, you can buy from Optimal Buy for $399 plus an additional 6.75% sales tax. You can get the iPod from Hamiltonian Circuits for $415, and then there's a 5% off coupon, but you still have to pay the 6.75% tax. Or part C, there's an online merchant in Portland that'll sell it to you for $441. That includes shipping, but you can get rid of that shipping cost because your friend who lives in Portland is going to visit you, and you could ask them to pick it up for you and then bring it all the way across the country and save you that 5% shipping. So let's see if we can go through the different pieces here. So first one is $399 plus 6.75% sales tax. So what do we do there? Okay, that is one very quick way. Yeah, that's a very quick way to do this, right? You take your 6.75%, and then we'll add. All right, so how much is this? That's the, yeah. So 425.93, good. All right, so that's what you pay altogether. Or we could buy it at 415. There's a 5% off coupon, and then you pay your sales tax. Which one do we do first? Do we take off 5% first and then add the sales tax? Or do we do the sales tax and then take off 5%? Or does it not matter which one we do first? All right, so let's do the 5% off first. Because you have a coupon, right? You hand them the coupon and they take it off and then they charge you the tax. Okay, so let's take off the 5%. Tax it at the end on the total, right? So 415 and then multiply by what? 0.05. Okay, and then we do 415 and then subtract off. What is it? 394.25. So that's the discounted price, but what do we still need to do with that? Sales tax. Casey, what times 6.75? 394.25 times the 0.0675. What do we get here? 2661. And now what do I do with that? That's the sales tax. So we got to add that to the 394. 394.25 plus 2661. Or 2086. Okay, so that feels better to me than the one from Optimal Buy, right? Save about $5. Okay, and then last one here is this online merchant business. By the way, there is a shortcut that you can kind of cut out some of these calculations. Instead of just multiplying by 0.05 and then subtracting, what you could do is say, okay, if you have 5% off, And what percent do you actually pay? You pay 95%, right? The coupon never says pay 95%, so this is not a natural thing for you to think about. But 5% off is the same as paying 95%. And so I'm just going to write here, if you just do the original 415 and you multiply it by 95%, do it on the calculator. I'll do it in my head because I'm just that smart. But it's the same that we got before, right? So instead of subtracting 5%, let's just think about what you actually pay. So we didn't have to go through this intermediate, calculate the $20 and then subtract it. We just think about what we pay. And you could play the same game here. Instead of finding the tax of $26.61, you could just say, okay, if it's a 6.75% sales tax, what percent do we actually end up paying at the end? Is 106.75%. So I'll continue over here in black. If I take my discounted 394.25 and then I add in the 6%, I'm just going to multiply by 1.0675. And again, I'm a human calculator, so I'll do this in my head. 420.86. So I'm not saying you got to go with the, the real quick process here, but I am saying there's a quicker thing than what might be natural to do. Okay, so let's go with option C now. 441, well, that's already higher than anything else, but that includes a shipping cost of 5%, which we don't have to pay. We can avoid that shipping cost if we ask our friend to trek across the country with our little gadget here. So what do we need to do? Well, the 441, is it going to go up or down? It's going to go down. We're going to have to subtract off what? 5%, right? 5% is already included in that number. Okay, so then this part C is right here. So what am I taking 5% of? So 441 and then times 0.05.
Sure.
How much is that?
2205.
And then we take our 441 and subtract. Or what is it? 1895. Okay. Griffin says it's not 5% of 441. Everybody hear Griffin's claim here? We believe him? It is, it's a shipping, but it's 5% of whatever you were supposed to pay originally, and then that should bring it to 441. So I guess we can test out Griffin's theory here by taking 5% of this number, right? I mean, like what we're saying is that the original cost was this 418.95, then they added 5%, and they got up to 441. So can we just verify? Yeah, let's find 5% of this number and see if it brings us back up to the 441. So 5% of 418 what is it? 20 about 2095.
Then you get 439.9.
And if we add this processing fee to the 418, we get 439. We didn't get 441. This 418.95 is not the right number. It wasn't what they added 5% to. And Griffin's exactly right. You can't take 5% of this big number, subtract it, and then take 5% of the small number and hope to get back up. 5% of a bigger number is not the same as 5% of the smaller number. They took 5% of the unknown and they built it up to 441. And unfortunately, as Griffin is observing, it's not as easy as just taking 5% of the big number and subtracting it off.
Yeah.
So in addition to catching our error, Griffin also provided us the solution. He said, really, you have this unknown number here. They added 5% to it, right? Which means it's really 105% of whatever it used to be. So what we know is that from the original up to the end, it's 105%. So here's what we have. 105% of the original price is supposed to be the 441 that we end up paying at the end. I don't know what the original price is, so I can't just go around taking 5%, but I know that I'm going to pay 105% when all is said and done. Okay, so remember all that algebra that you guys know and love? It's coming back here. So let's call this original price X. 105% is 1.05. So there's an equation you can solve using algebra. 105% of X, 1.05X. What do we do to both sides? Divide. What do we get? 463 is too big. It's got to be smaller than 441. 420 even? Okay. Good. You guys smirking back there. I have no idea what you're smirking about. All right. What's that? Because we are trying to solve this equation right here, and it's 1.05 times something that I don't know yet. And so we got to solve this equation by dividing by the 1.05. It's like if you had to solve 3x equals 6, you could divide both sides by 3. Yeah. All right, as a quick check, take 5% of this 420. That's the original number. What is 5% of this guy? Yeah, it's $21.
Yeah.
And if you add $21 to this, you get exactly the 441. So this is the right answer. Griffin found the mistake and then showed us how to solve. This is the tough one. People have such a hard time with taking a final number that's been found by going up or down a certain percentage from an original, because your intuition is wrong. Our intuition said, oh, we'll just take 5% off from the 441, but it doesn't work. So just be really careful. If you are given a final number, this 441 included something, those are the tricky ones. The other ones, I gave you the starting point and you just follow your intuition by adding or subtracting the percentages. But if you know the ending number, that's the tricky one. Okay, so which was the best option here? That's 420. We save 86 cents. I don't know if it's worth putting out your friend for 86 cents, but that's your call. All right, number 5. Casey, did you read? You did. Evan, please. All right, so percent increase and decrease. If you start with a quantity Q, like some original price, and you increase it by X percentage, then here's what you end up with. 1 plus X over 100 times Q. We're going to use the formula. I'm not a fan of memorizing the formula. I don't gravitate to these formulas naturally. But these are formulas that you can have, and they'll be on the reference sheet. So let's try to use them. We'll go to number 6. Ed. Okay, so we're going to try this with one of our formulas here. I'm going to say that probably some of you already have some method, something to do with these numbers that will tell you the percent increase. We're going to write both options here just so you see them. I'm going to first start by using one of the formulas. We can use these formulas for a lot of stuff, so they're kind of useful. Okay, so it says you end up with a certain amount and you started with a certain amount. So the I and the Q are the two numbers that were given to us. Q is the starting quantity. What is it in this problem? Is the 12,875. So we're going to use this formula right here. The Q is 12,875. In the parentheses here, I'm just going to put the 1 plus X over 100. The I is what you end up with. It's the 13,029. In X, in the formula, what does X stand for? It's the percent. And that's exactly what we're trying to figure out. We're trying to find what the percent increase is. We're trying to find x. So we're going to solve this equation for x. Everybody see where the parts went into that equation? Okay, so we solved this for x. There's an easy way and a hard way. The hard way is to distribute this 12,875. So you guys know you're supposed to multiply that by each of the two terms, right? Maybe if you had Sandy, you called it a lobster claw. Okay, that's the hard way. Easy way is to just say, okay, right now, somebody has multiplied by 12,875. What's the opposite of that? Divide by 12,875. So let's do that both sides. Most of the semester, we've avoided doing lots and lots of algebra. Today, we can't. All right, calculator folks, what is this number? What is it, 012? Is that exact or does it keep going? Okay, so 1.012 equals, and then I'm going to copy what remains on the right-hand side. The reason we put the 12,875 there was so that we could just cross it off right away. So all we have is what's in the parentheses, but parentheses on their own don't mean anything. Exactly. Right. So we're just trying to solve for x. That's it. So what needs to move next to get away from the x, the 1 or the 100? The 1. So go ahead and subtract that 1 from both sides. I don't need to see you guys writing -1, but if it helps you, then write it. Left-hand side is just 0.012. Right-hand side is x over 100. Right. Last step, what's the opposite of that divide by 100? Multiply by 100. Times 100 times 100. They cancel here. And then 1.2 over there. 1.2%. So 1.2% isn't that big a deal, right? So was this a big change or not that big? How long did it take for this change to happen? 1 day. So I'll ask again, is this a big change or not that big? It's big. It increased by 1% in a day, right? 1% in a day. So the folks that had like $1 million, I don't know these folks, but there are folks out there that had $1 million invested on this day. 1% of $1 million is $100,000. That's what they made on their investment. Am I right? 10,000. 10,000. Well, to them, it's all the same. But the people that had $1 million invested, they made $10,000 that day, which is a pretty big deal in 1 day. Okay, so I said that there's another option. I'm going to write a formula that I'm not going to suggest that you memorize, but I think some of you probably already know it, so I just want to include it. Cover your ears. Yeah, Ed was covering his ears because he doesn't want to see it. So what you could do to find percent increase is you can take the new thing, subtract the old thing, divide by the old thing, and multiply by 100. Raise your hand if that kind of formula looks familiar, like if you maybe have done that calculation before. I see a couple of folks nodding. So if we do that here, we take the new, which was how much? 13,029, subtract off the old, oh yeah, 0.50. Subtract the old 12,875. This is why I don't like this formula, or I don't like having to memorize it, because people forget whether you divide by the old one or the new one. And you get different answers depending on which one you do. It's supposed to be the old, which is which one? 12,875. Multiply by 100. So the folks with the calculator, you type this all in very carefully in one shot. You see, carry the 1, 7, 6, 4.2. You guys didn't realize how good of a calculator I was, right? I'm 3 for 3 on these mental calculations, which is really impressive. I don't know. What's number 7? Okay, 7. Yeah, so let's give this a shot. I think we're up to Mary. Can you read 7, please? Okay, so can you guys try that one? I don't encourage you to use this percent increase formula. I would encourage you to use this decrease formula. Either of these guys is fine. Use the decrease one for this and see what you get. Okay, so it looks like groups have come around to the answer of 4%. Yes.
So through here, so it'd be like, so it would be -4 equals -x.
Yes.
So wouldn't you add the x to both sides because you can't leave that x?
You could add x to both sides. Easier is to multiply both sides by -1.
So multiply by.
Yeah, both sides.
So it'd basically be -x multiplied by -x.
Multiply by -1.
Yeah. So that would be. So it'd be -4. So it'd be.
Yes, times 1 and then the negative.
So -1.
And that's just 4, right? Okay, let's put that away, please. All right, Okay, so what happened? The folks who were really rich and gained that 1.2% on the one day, what happened the next day? They lost 4%, quite a bit more than they had gained in this first day. Okay. All right. We good? Yeah, all right, keep going there. Aileen, could you read number 8, please? Thank you. Kate? Okay, so if somebody told you that that crime decreased by 200%, what do you think? It would be Happyville. Is it possible for something to decrease by 200%?
Well, yeah, it depends on the context.
What kind of context would? Hmm? So, okay, so if we could end up with some negative, then decreasing by 200% is okay. But what's, right, that's creative, track good deeds. What's the smallest percent of crime that we could have? The smallest number of incidents of crime that we could have is 0. And if you start with 450 crimes in a given year, and then you have none the next year, that's what percentage decrease? That's a 100% decrease. You've gotten rid of everything. There's no way we could have 200% decrease unless we somehow had negative crime that we could keep track of. Right. All right. So so let's actually calculate the correct answer here. So we want to figure out what the real percent decrease is. Same idea as up above. Are we using the first formula or the second formula? Second one, it's not a big deal. First one is the increase formula I. Second one is the decrease formula D. It just means you're going to get a negative answer if you use the wrong formula, but it's okay. All right, which one goes first on the equals here? Is it 450 or 150? Well, which one is it? So the formula tells you what you end up with, and Q is what you start with. We started with 450, and we ended with 150. So what goes here? 150 is what we end up with. 1 minus x over 100 times 450. That's it right there, right? Which means you can't just go around always putting the bigger number first by itself on the equal sign. You got to be really careful. Chad? We're solving this equation and we're going to get that 66%. I'm guessing, yeah, I think multiplying by negative 100 is the easy way to get rid of that negative sign. Just rounded it after 3 or something. Yeah. So it's something around 67%, depending on where you round. Any questions on that one? Okay, so there was a decrease in crime of 67%, which is great. Any sense of where that 200% number came from? Even though it's wrong, where did it come from? Yeah. What if we just start with the number 150 and we try to make it get up to 450? Go the other direction. If you take 200% of this 150, what do you have? That's 300. And that's exactly how much you need to add to get up to 450. So he did it the wrong way. Like this is the same, and Griffin is helping us again for it's the same issue that Griffin helped us with before. It's like, what is the reference that you're comparing to? If you're comparing to 450, then it's a 66% off. But if you're comparing to 150, it's a 200% up. And so you got to be really careful what the baseline is. Okay, let's move on to number 9. And I think we're back to Brandon. Okay, thank you. So let's take a look at this question. It's good marketing. All right, so here's what we're going to do. Here's my suggestion for this problem, is just make up a price for this random toy. You can make up any price you want. You can call it $7. You can call it $83.20. I'm always going to call it $100 because that 100, I'm even, 10 is easy, but I think 100 is even easier because 100 therefore is our natural baseline percentage number. It's out of 100. So for example, suppose the toy starts at $100 and after all this stuff ends up at $98. What percentage off is that? That's 2% off, right? And it's really easy to do that. Going from 100 to 98 is 2% off. What if it ended up at $112? Then that's 12% up. Whereas if we go from $10, then you'd have to know, okay, at $9.80, what is that? And there's still some work to do. So I'm just going to pick $100 for my baseline original price. So you are free to do this. You can pick any number you want. As long as you follow the process, you'll get it right. What's that? So we're actually going to, yeah, it's a good question. Yeah, let's use the formulas in turn. So the first formula that we're going to need is going to involve marking up by 80%. So we can do the increase formula there. So I'll just write it here, 80% increase. So the formula said I equals 1 plus, now for the first time today, I'm telling you what X is in the formula. X is the percent increase, 80. X is always divided by 100 times the original. What was the original? It was $100. That's the choice that we made right there, okay? And you can do this without the formula. I mean, the answer is 180, right? Like it's really easy to just go up 80% from $100. But I'm just showing you that you can use these formulas over and over again, as opposed to memorizing like 6 different formulas that are a little more efficient in 6 specific kinds of problems. Ed? Good question. Ed wants to know if we can just do 40 and 25 and say that's 65%, and it's coming off of 80%. Now Griffin is shaking his head, and Griffin has bailed us out several times today. Griffin thinks no. That's right. Yeah. Yeah, maybe. Yeah, so now it's $180, but they're going to put it on sale for 40% off. So let's see, 40% decrease. Let's see what we have here. Okay, so let's use the D formula. You can just do it, but I'm just using the formula. What do we have here? 1 minus. It should be X over 100. $40 over 100. And then times the 180. So this is our percent decrease formula. Okay, what do we have here? 108. Okay, what's the last thing we need to do? 25% off more, so let's do that. 25% decrease. We'll use our same D formula again. 1 minus X over 100. How much is X? It's 25. Out here goes the most recent number, which is 108 in this case. Okay, what did the toy buy this? What did the store buy the toy for? $100. What did they sell it to us for? 81. Is that a profit or loss for the store? Loss. For how much? 19%. 19%. It's really easy because we started with 100. So 19% loss because we started with 100 and we ended up at 81. This is really strange because, again, our intuition is kind of what Ed was saying. Hey, look, if it's 40% off and then another 25% off, that's 65% off. That's natural. It's intuitive. It's also wrong every time. At 19%, where did it come from? Like, I can't imagine anything that I could do with these three numbers, 80%, 40% off, 25%. I can't imagine anything I would do with those three numbers to build the right answer of 19. I mean, good luck. 80, negative 40, negative 25 to build 19. It's really not intuitive, which is why you just kind of have to go through the process. It's okay not to use these formulas, but you got to go through step by step. There's no shortcut here. Okay, moving on to 10, I think we are around to Lila. Great, Jake. Thank you, Damien. Okay, so today we're just talking about simple interest, which is different from how you get interest in your bank, because let's suppose you have $100 in your bank today and they give you $1 at the end of the month. So you're up at 101 now. Are they going to give you another $1 the next month? Is it going to be more or less than another $1 that they'll give you? They'll give you a little bit more. because now you don't have $100 that you've loaned them that they can do what they want with. You have $101 that they can play with. So they'll give you a little bit more. And that's called compound interest, and it's more complicated. But for today only, we're going to talk about simple interest, which assumes that the interest you get is going to be on that 100, not on the 101 that's there the next month. It's always just on the flat original amount that you put in. Okay, so the simple interest formula. Barb? Yeah, that's good. Okay, so this whole APR business, you just need to translate that in your mind to interest rate. It's a complicated looking expression. The annual percentage rate is just the interest. Do you get 5% a year? Do you get 1% a year? That's what we're calling APR. So let's go to IDA for number 11, please. Okay, so let's give this one a shot. So $1,000 invested on the day you were born. We are looking for how much you are going to have on your 18th birthday. Is that a present value or a future value? That's a future, sometime in the future. So what we are looking for is F, which means everything else in this formula had better get filled in. P is the present value or original value. The business word is principal. How much is it? $1,000. That's what gets invested initially. 1 plus R. R is the interest rate. What is it? It's 5%. The interest rate is 5%. But there's this really important note here that says you've got to write that thing as a decimal. 0.05, which is different from using the formulas we had up above, where when we said 40% off, we just put 40, but there was 100 built into that formula. So this guy needs to become 0.05. And that gets multiplied by T, which is time. How much time passes here? 18 years. So that's what we need to calculate. And I know it's just another formula, but I'm hoping it's not really one of these like mysterious, okay, Ian says this formula is true, but it's reasonable. This 5% times 18 is that's just saying how many times do you get that 5%? Yeah, you get it 18 times. And so we're going to take however many times you got that 5% and give it to you. You started with $1,000, great. We're going to give you 5% interest 18 times. That's the 1,000 there. Why is there this 1 plus here? Yeah, if we multiply this times this, what do we get? 1,000. You still have the 1,000 that your parents put in there, plus the interest that it gained over the course of 18 years. So it's got some different pieces, but I'm hoping it's reasonable. All right, then the next question says, what's the value of the bond on any given birthday? So here, I guess we're changing one of these letters back from a number into a letter. Which one of those is supposed to be general in this follow-up? Is the T, is the time. So let's just copy the formula, but we'll leave T as T instead of making it 18 like we just did. So let's try that. F equals 1,000 times 1 plus 0.05 what? T. That's it. Some math students are not satisfied unless the final answer is a number. There's your final answer. It's a formula. In some sense, it's more useful than the blue because here you can plug in any number you want. If you're 30, if you're 40, if you're 80, you could just plug in and just out comes the how much money is in this account for you. Yeah, be really careful when you're writing plus signs and T's. Okay, number 12. Where are we now? Sana. Okay, so you guys are going to work on this one, but let's just be really clear. This $1,000, is that what you put in or is that what you get out? That's what you get out. So you're going to put in more or less than that. Better be less. You're going to put in some amount less than 1,000. It's going to grow over the course of what, 5 years, and it's going to at the end of 5 years, it's going to be worth exactly how much? $1,000. So work with your neighbors on this one. Okay, so $823.72. You put that in today. 5 years from now, you take it out, you get $1,000. Okay, that's how they work. Okay, so one quick anecdote here. I was at one of these like Black Friday crazy, like 3 in the morning, stupid things, and I was at this store, like a clothing store, and everything in the store was 20% off, just flat 20% off. And then there was like this discount rack, which was 30% off. And so the salesperson is trying to convince me that the stuff on the sales rack is therefore 20% plus 30% is 50% off. I'm going to show you my teacher ID card. Come on, you can't pull this with me. 20 and 30 you can add, and it's not 50. So here's my question to you. It's not in the packet. Everything in the store was 20% off. The clearance rack was also 30% off. I was claiming to this person who remained unconvinced that it is not 50% off. So I would like you guys to tell me what percent off is it really? 20% off and another 30% off with your neighbors. See if you can answer this question. 20% off and another 30% off. What is it really? What is the discount really?